Welcome to lesson 7. Pause the video, have a go in your own time. There's the question at the bottom. Just a little thought about this particular lesson. I'd say there's quite a few more difficult questions here. I've just made lesson 7 a bit more awkward. It just felt like the right thing for the learning progression, so if this feels particularly hard, hang on in there, it's fine. So let's have a look. This one, I've no idea. I'm going to use the technique called make it look the same. Make look same. I'm just saving time by writing less words. Right. Well, I guess I could make all the fractions have an 8 at the bottom. Let's make that happen. So then that's a z. That would be a 4 because I've had to times the top and bottom by 4. This one would be a 6 if I had to times the top and bottom by 2. And then that means I can then use, I'll change colour, by inspection. By inspection, if I've got those fractions, the top bits must be true. Otherwise, the whole thing doesn't work. In which case, what's z? Well, z is obviously equal to 10, because 10 minus 4 is 6. And I think that's a legitimate way of answering this question. And also, this is an insight into advanced ways of solving much more difficult maths problems where you're having to play around with things to make them look similar. Because you can't always just throw plus, minus, times and divide at things. Sometimes you have to be more subtle. Blah, blah, blah. Anyway, and obviously, if you're tired of my waffling, you can just jump to the next question. Just as an aside, if you had done this the traditional way, you could have just times everything by 8, which meant you would have ended up with z minus 4 equals 6. So it would have been exactly the same thing, and then you add 4 to both sides, it was z equals 10. And again, someone might say, yeah, but Duncan, why did you do all this faffing, which I've just highlighted in yellow, if you could just do it the way you did in red? Well, the answer is because we're trying to consolidate a couple of important, more advanced techniques for problem solving, because you cannot always solve maths problems simply by doing plus, minus, times and divide. At which point you have to be more creative. It's kind of one of the interesting things about maths, which is that at advanced levels it can be quite a creative subject. Have a go in your own time. Welcome back. I'm going to simplify first. I'm just going to go, oh look, 3x minus x, they're both just multiples of x, so that's 2x equals 20. Really important that you simplify every opportunity. Then I'll divide by 2, which leaves me with x equals 10. So remember, simplify, simplify, simplify. Every time you see an opportunity to simplify, go for it. It's a good thing to do. Next question. Have a go in your own time. There's 2 equations there. Or are there? Let's simplify the top equation. Oh, 5x minus x is 4x. We effectively have exactly the same equation repeated, which means we only have one equation and we have 2 unknowns. Therefore, not possible. In case you're still listening to me and you haven't fast forwarded yet, I'm just going to briefly mention one of the reasons this is important. When you're doing more advanced questions in a maths exam, for example, I don't always like talking about maths exams, but it's a thing. And this is true in real life as well, if you're using maths at work or something. Sometimes you're trying to solve a problem and you have loads of information about it and you start trying to solve it and you go, oh, I think I'm there, I've got a couple of equations, and you're like, no, I still can't solve it. So it's good to have that big picture so that you can look at something that you're trying to solve and go, oh, the reason I can't solve it is because I need another equation. I don't have enough equations yet. If that made any sense, what I just said. Okay, here we go. Have a go at this in your own time. Welcome back. Did you say not possible? That would be wrong. In fact, it is possible. Ish. We can use by inspection. Look at this. The 7s are on both sides. There's a plus on both sides. There's an x squared on both sides. And then there's this thing next to the x squared. So the thing in red has to be the same. Therefore, a equals 5. So we can say A we know, but we don't know, but X is unknown. That's the way of answering that question. Why have I, remember I did say that this lesson is a bit more complicated. So I've done it partly because I always think students need a point during their learning where they just get the bigger picture. So I'm just partly just trying to deliver a bigger picture here, which is there's some other stuff going on. We're homing in on useful tools. It's set within a wider context. Anyway, blah, blah, blah. Right, let's do the next question. Have a go in your own time at this next question. Is the answer not possible? Correct. It is not possible. You can't do it because, oh look, there are two unknowns and there's only one equation. Let's do the next question. I might run out of room here. Okay, can you still see that? Yep, you can still see it. We're fine. Have a go in your own time. Okay. Well, there's 1, 2, 3 different types of variable. Well, let's see what we can do. Let's do some by inspection. There's a 5 on each side, there's a plus on each side, there's an x on each side. Oh, there's a number in front of the x, then there's a plus, then there's an x squared, and then there's a number in front of the x squared, which means we can see that a is 4 and b is equal to 9. And then we're going to end up with both sides being exactly the same, which means we're then going to have to say x equals unknown. Could we solve for all three unknowns? No. Could we find two of them? Yes. Now we're going to do a same to both sides exercise, which, if you're keeping track of my capitalization of titles, I have this habit of not capitalizing same to both sides. Okay, I've caused problems myself here. I'm going to have to shift the page a bit. Okay, let me tell you what that is so you can get started if you want to. Yeah, I'm a bit unreliable when it comes to capitalizing titles. I think I see same to both sides as being kind of a phrase, and I'd slip into a different sort of grammar, but I'm not using consistent styling for the document. So if this were like a group, a written project, I might lose presentation marks for that. I'm just waffling on while I talk, really. There you go. You've got 4 same to both sides to attempt. See you back here in a minute. Okay, so if it's a times, I have to do it to each thing. So that would be a squared b, because a times a is a squared, abc, acd, plus ade. Now let's do this one. If it's a minus, you do it once to each side. So that's AB plus BC minus B equals CD plus DE minus B. And that's it. That's the final answer. I'm going to talk about that in a minute in case you want extra help. Now I'm going to divide through by C. If it's a divide, that means it's a times or a divide, which means you do it once to each thing. I just did that wrong. Plus DE C. Again, I'll talk about that in a minute. I'm just trying to get the answers out so that people can check their answers. This is a plus, which means I'll do it once to each side. There you go. Jump forward if you don't need any extra help. Otherwise, I'm going to talk about a couple of things. First thing is, did you try and do this? Did you try and cancel the b's? You can't do that. That's not allowed because you've got two different objects. Remember what we were saying before? Imagine, let's use another example. Imagine you had 100 times 5 minus 100. That's 400, isn't it? Well, what if I then go, oh, I could cancel the hundreds? Well, now it's 5. Clearly it doesn't work. And I just want to briefly address something. Some students say, Oh, but it doesn't matter if it changes, does it? I'm following the maths rules. Well, here's the thing, right? The maths rules have to kind of keep everything the same. You're not allowed to just magically change things. Change things. I'm going to address that in a moment. Notice lesson 7 is a bit philosophical. But so if you're thinking, wait, I can change things sometimes, we're going to talk about that in a moment. But first, I just want to talk about this question over here. Notice if I do it fully, I could put the C and the C there, and I could put the C and the C there, but then they cancel, which is why I didn't bother writing them. Right, so you might want to skip forwards, or you might be thinking, yeah, Duncan, wait a sec. You just said that things don't change in maths, but I have seen things change in maths. So let's look at an example where they change and realize why that's okay. 5x plus 10 equals 50. And suppose we divide by 5. That means we get x plus 2 equals 10. So you might now be saying, haha, something changed. Look, a 50 changed to a 10. Okay, so here's the question. Why is that allowed? And the answer is it's allowed because that's an equal sign. All it's saying is the left-hand side is equal to the right-hand side. And yeah, sure, we did change to the right-hand side, but we also changed the left-hand side exactly the same. And therefore the equal sign is still true. Okay, right. Let's do the next question. This is a little run of solve questions, very similar to the one that we did previously, which means I'm just going to write them all out so that you can have a go at them all at once. I think that's probably the best way to do it this time. That's if I don't run out of paper. You can tell I'm old because I use the word paper. So if you're watching this on a colony ship heading to another solar system or something, yeah, I'm from the days when paper still existed. Okay, have a go in your own time. Obviously try and keep track of your answers. I'm going to add some lines just so we can see which answers which one. Okay, so this is going to be P equals 0 and or Q equals 0. This one is, well, that's obviously P equals 0 because 5 times something is 0. This one, 5 times something is 0, so this something here must be 0. How do we make that equal to 0? We do it by making P equal to 2. I'm going to change colours here. This one has two things multiplied together, so either P equals 0 or P equals 2. Because if P equals 0, the first thing is equal to 0. If P equals 2, the second thing is equal to 0. Why didn't I write and? I'll talk about that in a minute. This one here, P equals 10 or P equals 2. And then we've just got a little wonky one at the end here. What's the first one? The second one is obviously P equals 2 because 2 minus 2 is 0. What plus 10 is 0? The answer is minus 10. Right, I did promise that I'd come back to why isn't it and or? Well, I'm going to answer that with another question. Up here, why is it and or? It's because it's because there's a P and a Q. They're two different things. So they could both be 0, or maybe only one of them is 0. But over here, P can't be 0 and 2 at the same time. It can only be one of them. Let's do the next question. It's a little row here. I'm going to give the answers to this, and I'm not going to go into too much detail because I've got other videos that cover this in my other playlist. The one related to my maths book. I don't want to have too much repetition. This one is, oh, I've got to get it right, 81, 9. Remember the pattern. So I'm going to do the pattern the other way. You times by 9. This is what I call the times table. What do you times by 9 to get 9? 1. What do you times by 9 to get 1? What would go here? 1/9, because 1/9, yeah, so times 9. And then this one would be 1 over 81. And there's lots of other ways of thinking about these powers, which we'll kind of address later and are addressed in some other videos. Plot, if necessary. I've written if necessary. You're allowed to just kind of say what the rule is without plotting them if you like. What is the rule? That's the question. That's what the mark's for. Imagine it's an exam and there's like a 1 in square brackets, so we just need to know what the rule is. Right, well the rule is y equals x. That's the rule. I'm gonna do it in a different color because I always do it in a different color. Okay. Let's just prove it. You can obviously skip to the next question at this point. 0, 0. That point goes here. 1, 1, that goes here. -3, -3, that goes here. Minus 4, 4, that goes up here. They draw on a line. Oh, look, what's the rule? The rule is, in a sense, we don't even need the graph to work out the rule. We can just look at the points and say, oh, look, in each case, x is the same as y. How do we write that in maths language? We write a y sign, an equal sign, and an x sign to indicate that they are equal. And that they are in general equal. This is a rule that can be applied. Plot, if necessary. Got another one of these. So we're going to be asking what the rule is in a minute. Because I thought we'd do 2 of these today. This is, you know, I use like learning and repetition intervals, all that kind of stuff. This is kind of a consolidation day. Because I know that some people will be a little bit lost on the graphs, and this is just a little mini step backwards just to kind of consolidate it so we don't lose anybody. What is the rule? Answer. Oh my goodness. Got it. Y equals x plus 1. I'm going to draw a graph and prove it. You might just be skipping on already because you might be like, oh, I've already got it. But to me, this looks quite difficult. You saw me pause. Let's plot the first point. That, remember, it's x comma y because always in alphabetical order. So x is 0 and y is 1. Now let's plot the next one in light blue. X is 1 and y is 2, so that goes there, etc. We're going to end up with a graph like that. Now, actually, I'm going to plot one more point because a lot of people plot this particular point wrong. X is -3, 3, and y is -2. There you go. Right. Again, we don't necessarily need the graph. We can just observe that it's x on here on the left-hand side and y on the right-hand side. We can just observe that, oh, y is always 1 greater. And maybe you're finding the minus sign confusing. Scribble that out. It's more obvious. Oh, look, obviously y is greater than 1. And then look at this again. Oh, yeah, -1. If I look at the number line, -3 is here, -2 is here. Therefore, it's increased by 1 on the number line. Let's do the next question. Got a row of 4 here. Oh, I like this question. It's one of my favourites. If you can have a favourite maths question. A lot of my favourite maths questions are very, very advanced. In fact, if you're interested and you're at a high enough level, if you look at some of my playlists relating to my maths book, I've got some really horrific questions which combine different topics, and they're kind of probably my absolute favourites. But I quite like this question. I think it's quite an interesting one. Just because you kind of do it and you go, oh, for me, I go, oh, that's interesting. Let's just write the answers out. Have I just done times twice? Right. Whoa. Can everybody just take a pause? Let's all of us redo. Pause again. See you back in a minute. Right. Okay. Let's do it again. Half minus a half is 0. Half times a half is a quarter. Half divided by half is 1. I don't really feel the need to say anything there, but to me, I'm like, oh, that's quite interesting. Because do you remember we've done that before with just whole numbers like 2 and 3 and stuff. And to me, it's quite interesting to see how the pattern works with a fraction. 4 just random calculate questions here. Have a go in your own time. I think I said 3. Anyway, that's it. There's 3. I might have said a different number. There's 3 of them. Here we go. That's 16. That's 2, and that's 4. I've got a thought here. Should that be plus or that should be 4 or -4, shouldn't it? That may have cropped up before, and I may have missed it. This is debatable. It depends on exactly which topic we're doing. If you didn't write -4, it's okay-ish, but and I think I'd made that mistake earlier in one of these lessons anyway. It's let's not get bogged down. There's a good reason why. But in general, in an exam, I think I have made that mistake earlier, and I probably have lost marks on the exam. So remember, in general, let's include the minus. I'm waffling. In case you're confused about this one, let's first look at this one. That means square root, so it means what times what equals 16. Oh, 4. So then the one in red, that's the fourth root. So what times what times what times what equals 16. Then we're just going to deduce, let me think about this. Oh, it's 2. This is the last question. It's a factorized question. And there is a bonus lesson on factorizing on the playlist after this one. Have a go in your own time. It's going to have to be something on the outside. There'll be a plus sign and there'll be things on the inside. And what goes on the outside is going to be anything that they've got in common. They've got a 5 in common, they've both got an x, they've both got a y. So I now need to just make sure that when they multiply out they work. So here there's a y needed to make it 5xy squared. Here we need a 3 because 3 times 5 is 15. We'd need an x. There you go. I'll just write it out neatly. 5xy, y plus 3x. That's your answer. Remember, it's the reverse of expanding. See you in the next lesson.